In this video, we will talk about what a perpetuity is. So perpetuities connect to what we discussed in section 7.4, which was continuous income streams. And a key question that we answered there was, when a continuous income stream is deposited into an account that earns a constant interest rate, what is its future value? So how much is that going to be worth at some point in the future? And what is its present value? So recall that conceptually, present value is how much you'd have to deposit into an account right now and just earn interest on it. So don't add money to it, just earn interest. So that at the end of the time period, that will be worth the same as the future value of this continuous income stream. Okay, so in this section now on perpetuities, what we will try to ask and then answer is it possible to deposit some amount into an account that earns a constant interest rate so that you can withdraw? So another way I'll say this is sometimes I'll say fund. So you can withdraw or fund a continuous income stream. So you want to be able to keep taking out money, keep withdrawing money or funding something forever. So indefinitely. So this idea of being able to do it forever means that we are going to keep taking out money. And I'm going to write a synonym for doing this forever. A synonym for it is to say we are doing it in perpetuity. Or forever. So I want to motivate the answer to this question by looking at an example. So in this example, suppose that there's an anonymous donor who gives $1 million for a scholarship fund that is then deposited into an account earning 5% interest, continuously compounded annually. So I want to look at a couple of scenarios. In the first scenario, let's say that the scholarship awards one student $40,000 per year. So each year they're going to get $40,000 in a lump sum payment. So well actually no, I shouldn't say lump sum. I should say increments of 40,000 each year. Yeah, so I wanted to distinguish between lump sum because lump sum means you get all the money once and then that's it. So here I mean for this to be increments of 40,000 each year. Okay, and the question is, will the fund run out of money if they're giving away this much money each year to students? Okay, so I want to look at a table to investigate the answer. So t equals 0 is going to be the starting point, year 0. So to figure out the value at the starting point, well, I know at the starting point there's $1 million in the account, but let's subtract away the fact that they're going to give $40,000 to a student for scholarship. So let's say that they start earning scholarship right away, right at the starting point. And if you subtract these, we'll end up getting $960,000. Okay, and then after that point, the account is going to start to earn interest. 5% interest continuously compounded. So to figure out how much there would be after 1 year, I need to use the PERT formula. I need to use P e to the RT. Let's start plugging in for these values. So let me just write on the side P e to the RT. And P, the amount that starts to earn that interest is 960,000. So I will write 960,000 times e to the r, 0.05, and then how much time has elapsed? So this is 1 year. Okay, and then we need to subtract at the end of this year they need to subtract $40,000 for the scholarship amount. And when you work out that number, this ends up being about 969,220, which means it went up. There's actually more money in the account than there was initially. Okay, if we do this one more time, we would now earn interest on the $969,000. So we'll take 969,220 times e to the rt, 0.05 is r. And then how much time has elapsed on this amount, the 969,220 earning interest? Well, a year has elapsed from t equals 1 to t equals 2. So I'll plug in 1 for the time elapsed, and then subtract $40,000 for the scholarship withdrawal. And plugging this into a calculator, we get this is about 978,913. So even more money. So it looks like, based off of this, that over time, the amount in the account is just going to grow. So the answer to the question, will the fund run out of money, is, well, it seems like no. And if we were to plug in some more values, some higher values for t, we'd get that not only is the account value going up, but it keeps getting bigger and bigger and bigger. It keeps increasing by larger and larger amounts. So it seems like no, it won't run out of money. Out of money. And the conceptual reason why is that at the end of each year, two things happen. Well, let me say this. Over the course of the year, there's interest that the account earns. And then at the end of the year, there's the payment, there's the withdrawal for the scholarship fund. So there's overall more interest being earned than payouts for the fund. So by payouts, I mean the withdrawals that are being taken out to fund this scholarship fund. And that's making the account never run out of money. All right, so let's look at one more scenario now. So in scenario 2, let's say that the scholarship awards one student $40,000 a year, but continuously. And continuously means that they're not just going to be given the $40,000 at the start of each year. It's going to be paid out continuously over the course of the year. And that value is going to increase by 3% per year, continuously compounded. Maybe to account for higher living costs. So over time, the students earning scholarships will need more money because cost of living goes up. All right, and the question is, how much will the anonymous donor need to initially gift to fund this scholarship forever? So the answer to this, we will talk about in the next video. So I wanted to frame this question in this video and motivate it to hopefully convince you that such a situation might be possible, that it is possible to just earn enough interest so you'll never run out of money for whatever it is that you're trying to fund. But this specific question we'll try to answer in the next video. So in terms of our goals, we've asked this question about what perpetuities are. Is it possible to deposit some amount into an account that earns a constant interest rate so that you can withdraw a continuous income stream forever? And we motivated this through a couple of scenarios. And in the next video, we'll try to answer that question that we ended with. And I'll refer to that as the Aunt Grace scenario.